Hi, my name is Mark Hesse, and this is my oral presentation for Maths Curriculum Studies 2. The question I have been given is from Maths C, one of the core topics, which is part of the real and complex numbers. And it's a melting gold question, and the students are required they have a gold bar with those dimensions 5 root 20, 3 root 12 and 2 root 6 centimetres, and it's to be melted down into a cylinder height of 4 root 10 centimetres. So they have three parts. They have to find the volume of the gold, and they have to express it in the simplest third form and specifying the appropriate unit. Part B is to find the radius of the cylinder, expressing the answer in the simplest third form and specifying the appropriate unit. And the part C, the third part, is if the cylinder height was changed to 3 root 40 centimetres, what would be the new radius? And again, expressing the answer in the simplest third form. So what I would firstly like to see an A grade student do is actually draw a gold bar. You can see it's a rectangle, and put the dimensions on it, correctly label the dimensions as L for length, width and height, and then show that being melted down into a cylinder with a radius which they need to find and the given height. I would first like to probably see them review their previous knowledge, which is finding the volume of a rectangle, which is length times width times height, and also finding the volume of the cylinder, which is pi r squared times the height, and giving the correct units, which are cubic centimetres. I'd also like them to express their previous knowledge in relation to square roots, just to state that they need to simplify the factor or factorise the number inside the square root as small as possible, and to show the previous knowledge in relation to the rules where the square root of A times B is actually the square root of A times the square root of B, and the square root of A over B is the combined square root of A over B. So for the first question, part A, they have to find the volume of the gold, expressing the answer in the simplest third form and specifying the appropriate unit. What I would like them to see firstly is to try and simplify the dimensions, the square root dimensions further before carrying out the calculations. This would make the calculation easier later on when they perform them. So I'd like them to see them simplify the length, the width and the height, which you can see can be simplified. The height can't be simplified any further because the square root of 6 is actually is 3 times 2, which can't be simplified further. And to specify the correct units, which will be centimetres times centimetres times centimetres, which is cubic centimetres. Then I would expect them to carry out the calculation of finding the volume of the gold bar, which is length times width times height, and to substitute into the formula those simplified square roots, which is 10 root 5 times 6 root 3 times 2 root 6, and then using the square root rules previously, which is multiplying the numbers within the square root and the numbers outside the square root, and doing that calculation line by line, so that if they do make a mistake, they can pick it up as they go, but that will give them a result of 360 root 10. And just to state that you can't simplify root 10 any further, so that is the simplest third form. And I'd also ask them to check it by calculator, just rounding it to 2 decimal places, just to check that they have got their calculation right. So using the original calculation of 10 root 5 times 6 root 3 times 2 root 6, putting that in the calculator, multiplying that out to give to give 1138.37 cubic centimetres, and then also putting in the calculator, calculating 360 root 10, which shows you that they have got that calculation right, so that's okay. Part B is actually finding the radius of the cylinder, expressing the answer in the simplest third form and specifying the appropriate unit. Now, they're given the height of the cylinder, which is h is equal to 4 root 10 centimetres, and of course the volume of the cylinder was the volume of the gold was actually calculated in part A of the question. So they know that the volume is equal to 360 root 10 cubic centimetres. Therefore, using the volume of a cylinder, which is V is equal to pi r squared h, they can find the radius. I'd firstly like them to get the radius by itself before they actually put the dimensions, the numbers in there to calculate. I think that would be the best way to do it, and go through those calculations, which results in a radius of 3 root 10 over root pi, and that can't be factorised anymore or simplified any further. So actually specifying that the radius is 3 root 10 over root pi, and that will be centimetres, getting the correct units there. And then again, checking by calculator just to make sure that they have that perform that calculation correctly. I would probably like to see them draw the cylinder. It makes it a bit more visual. Specifying the height is equal to 4 root 10. They can calculate that into 2 decimal places, centimetres, and then actually calculating 3 root 10 over root pi, which gives them 5.35 centimetres, which means that the calculation is correct there. So they've checked that as well. Part C of the question, so the is similar to Part B, but the height is changed to 3 root 40 centimetres. What would be the new radius? So the same principles as Part B. I'd firstly like them to see if they could simplify the height. The third number, 3 root 40 centimetres, can we simplify further? Yes. And that calculation is 3 times root 4 times root 10, because the root of 40 is root 4 times root 10. And they can simplify that height before actually substituting that into the formula. And given what we previously worked out in Part B, that the radius is equal to the root of the volume over pi times h centimetres, they can then substitute the volume and the height into that formula, and they can simplify those calculations and that down to the simplest third form possible, which is 2 root 15 over root pi, and you can't simplify root 15 any further. So they can calculate the radius and specify that in centimetres. And to be consistent, check their calculations by calculator, similar to Part B, where they would put the height in, put that into the formula as shown, which will give them 4.37 centimetres, and also comparing that to the radius that they calculated, which is 2 root 15 over root pi, which gives them 4.37 centimetres. So they've checked that's okay. They've checked that their calculation is correct there. So that's the first part of my oral presentation. Thank you.